Hello, and welcome. Happy Friday. This is the deep dive in its original time slot here, Friday afternoon. For anyone who's new and doesn't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. This is the deep dive, which is a weekly live stream program centered around CircuitPython. It was started by Scott Shawcroft, lead developer of CircuitPython. He is off today, out doing some other stuff, so I'm here to fill in. And as the title card said, I am actually doing a similar stream now on Tuesday mornings, so if you would like to catch me then, working on other CircuitPython stuff, you can do that on Tuesdays at 11 a.m. Eastern, 8 a.m. Pacific, or 10 a.m. Central time. Those are US times. And we do have daylight savings time coming up, so that will get adjusted for that. But today we are here on Friday, filling in for Scott, and working on some light sensor drivers. But before we dive in, let's do a little bit more of the intro. So I think I mentioned the stream is about CircuitPython. If you don't know what that is, you can learn more about it at the main website here, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. Already at full size. Tiny computers called microcontrollers, and the way it works, typically, you will plug these things into your computer with a USB cable. They show up like a thumb drive. You can edit a Python code file on that thumb drive, and when you save it, the microcontroller will run the Python code that's in there for you. And then you can interface with whatever other peripherals you connect to your microcontroller. So you can add sensors and lights, buttons, beepers, buzzers, speakers, screens, e-inks, all kinds of stuff. And you can control all that stuff with Python code if you use CircuitPython. CircuitPython is open source. It is all funded by Adafruit. Adafruit is a hardware and software company based out of New York. They have a website here, adafruit.com, where you can purchase hardware from them. They design and manufacture not only microcontrollers that run CircuitPython as well as other types of languages. They also design and manufacture sort of modules, plugins, bits and bobs that you can hook up to your microcontroller to do other stuff. And in particular today, I am looking at this APDS. Do I have that right? Just let's take a very, very brief, APDS. Okay, thought I had that backwards for a second. APDS 99949s, which is a proximity, so distance, and then lux light and color sensor. So this can sense RGB. It can also actually sense IR as well, which it doesn't list here. And it can get a lux value for how bright it is. It can get the red, green, and blue channels. And then, like I said, it can also do IR, I believe. At least the driver thinks it can. Does it say anything about IR here? Wire. IR. Proximity sensing, yeah. Well, okay, so the proximity sensor uses IR. Okay. In any case, so yeah, you can get yourself all kinds of bits and bobs to plug into your microcontrollers here. Huge thanks to Adafruit. They make CircuitPython possible by paying a team of folks, including myself, as well as Scott, who I mentioned before, to work on the project, and lots of other open source software as well. So if you want to help support them and CircuitPython and all of the other open source software that they fund by paying people to work on, you can do so by purchasing hardware from their website at adafruit.com. And I will say keyboard week, keyboard sale week is what we're on right now. So there's lots of keycaps and other keyboard peripherals that are discounted right now. It is the last, I'll say, couple of hours or days. I don't actually know when it ends. So if you want deal on keyboards, you better get it soon, because I believe at least by next week there will be a new category. So these things will go back to regular price. The new category will be on sale. So check back out on the site next week for the new category, and get your keyboard stuff now if you want it. And with that, we will jump over to the camera. I will show you what I have set up here. APDS 9999, like I said. It will be hard to show you right now because of the way the light is, but I have it wired up there, and I basically just have it sitting in front of the light so that it can shine its own neopixels on it. And I have been working on the driver for this today. I have some of basically the most sort of basic test code here, but what we are going to try to do is build this into more of a kind of test, a validation that more parts of it are working as intended. And I think we are going to do that by first taking the example we have, drop it into examples here. And we more or less want to replicate the examples that we have in Arduino. We don't have TFT hooked up, so we won't be doing that one. Proximity will do. Threshold. Is that on light or? Yeah. No, proximity. Oh, and light, actually. Proximity and light. Okay. We get into that. That one's a bit more advanced with the interrupt. I'm not sure if the wiring on the interrupt is going to work or not, so we will have to see when we get to that. But I will start. This one's basically what we have right now, although I'm not printing the lux, so we should do that. Right now, I actually am printing RGB, which is... Push this away first. I don't really need to see this. Okay. Oop, and now this has no... It's convenient. There we go. Okay, there we are. So one thing I'm going to do right away is turn this back down some. Doesn't need to be quite so bright. And that for now. In fact, that's quite a bit less bright. You're probably not going to be able to tell too much from this because it is just still overwhelming the camera since the camera's pointed more or less right at it. But we have pink light from the NeoPixel, and we're reading pink RGB from the light sensor, which is good. We are on gain 9. It goes up to gain. We could go to 18 if we wanted. Which would kind of double the effective outputs of that. And we could, of course, obviously crank the brightness back up on the NeoPixels, which would also crank those values up. We could drop the gain back down if we wanted. So those are kind of analogous to each other. We could turn the brightness up, and that will lead to higher readings. We can also turn the gain up here and use a lower brightness, and that will still lead to higher readings. So we basically have the color testing code that I want. Which is this. All right, we're going to add lux to that, though. So right now, we're just printing RGB. We can easily add lux. So if you just comma... Well, so the thing is, so in order to get lux, we actually need the green value. Somewhat frustratingly... actually we need not only the green value, but we need the like raw green value, not this RGB. So the thing is, I kind of added this RGB property that is like a simplified sort of version of RGB IR. So there's this one which lets you get raw data out of the sensor up to 20 bits of resolution, although we should actually modify this little string here, the stock string. Each value is up to 20-bit count, read in a single 12-byte burst. Yeah, starting at this. C, it's called light resolution. Yeah, light resolution. For bit depth setting. Lower resolution will result in lower maximum values. I did figure this out a little bit ago. But yeah, if you have the resolution set on max, you get 20 bits of range for each color, which matches this range right here. But if you have the light resolution set lower, which it comes that way by default, then you get a lower value. That did not really. And then what you need for the lux is you actually need the green that this returns. Although, does it matter if you're in RGB mode versus calculate luminescence in lux from a raw green channel count? Reads the current light gain and resolution settings from the device, amplifies to the appropriate scale factor from the LUT below. 13-bit resolution is not supported, so we're not doing. I don't think I'm doing that one. The one thing this does not say is it gets the green. It's the raw green value, but there's actually this thing, RGB mode. RGB mode versus ALS mode. What is ALS mode? What would that mean? I don't actually know what that means. ALS. Light sensor and proximity. Operated independently in parallel. It can be configured to run ALS or RGB. Between the sub-modes of light sensor and the activation of the sensor channel. ALS is offered for more power savings if the full RGB is not needed. I don't know what ALS means. So will you not get colors? Do we have RGB mode true? If I set that to false, it will go to ALS mode. Okay. Yeah, in ALS mode, we are getting green, but nothing else. And if I cover it up, then we don't get green anymore. So yeah, in ALS mode, we're kind of like only sensing green. But that's fine because green is what we need to pass through to calculate the lux. Okay, so let's go RGB IR is equal to sensor RGB IR. I'm going to put this back to true, but we now know it should work for both. RGB IR, and then print I want labels on these. And we can do lux sensor plate lux. That takes the green value. So that, and then lux is back as 1048 right now. And if we look, I don't know the scale exactly, so I don't know. One thing we can do is just make sure it goes up if it gets brighter. So right now we have like 36,000 raw data green. And that's giving us a lux of around 1048. I am going to cover the lights. I've been using this here. Here basically makes this nice like glowy effect, but I'm gonna raise this, and I don't want those just blinding me while I sit here. So right now we're on 20%. Let's try 75% and see. So first of all, the lux did go up by about 10 or so just by covering it. More of the light is like contained underneath there. Yeah, there we go. So we went up. Now we're closer to 4,000. We have much higher absolute values. Actually, in this case, we have reached the maximum of the resolution. This is the maximum of the current resolution, which is 2, but that's not very helpful. So that would be 0, 1, 2, 18 bits. Basically, it doubles how long it takes if you want more resolution. We are maxing it out though, so we could drop the gain here instead. Yeah, now we're back under the under the maximum. And the lux calculation is still the same, which is good. Around 4,000. Okay. Okay, so that's looking good. This is basically the color. This is basically the color example. Which I'm actually just, well, so should we call that simple test? I feel like we should just call that simple test. That's basically what the simple test usually is. I have been trying to just do everything in my T lately, to just keep everything all the same. Okay. Set those down a bit. Alright, I'll write this out later for simple test showing the APDS. Probably we won't do gain. I don't know, maybe we'll set the gain to something less. The thing is, you kind of need to tweak the gain and the resolution to your own situation. It kind of depends on your environment. But one thing that I do want is I want like not a test that illustrates how to use the driver, but a test that validates that the driver is working as intended. How does the APDS 99 compare to the OPT 4048? Good question. I don't know if you spied that in my IDE or not here, but I actually have the OPT 4048 open as well. One thing is the types of data you get back, like the OPT 404. It is technically based, and like I'll preface all of this with I don't actually understand the color theory or the light theory behind it, so I could tell you what the differences are in the words that I see in the code. If you understand light theory or color theory, you might know what that means better than I do. But yeah, so with that prefaced, the main thing I think is that the OPT 4048, it has these XYZ values, and it also has the CEI thing. And it gets those things and it converts them through all, through this sort of magic math right here to get the RGB data. The APDS 999 driver does not do that. It just reads 20 bits up to 20 bits of data for each color, as well as IR, and they're ready to go. They just have the values, the raw values. I created this, well, it's not here in this copy of it, but I did create one that maps them down to 0 to 255 to make it convenient for display IO and NeoPixels and stuff. But the raw data just comes out as 20 bits, up to 20 bits resolution. There's no calculation after the fact. So it's not doing the XYZ thing. It's not doing the CEI or CIE thing. It's just reading straight up. And then I believe the resolution is much higher as well. So up to 20 bits, I believe, is higher. Doesn't say anything about resolution. I don't know off the top of my head what the resolution of the OPT 4048 is, but I don't think that it is that high, honestly. This one can do the color temperature, which has to do with the CIE, so I don't believe the APDS can do that. Another one that I would say is a big difference, right, is proximity, isn't it? Proximity? Yeah, so the OPT 4048 does not do IR, which I guess is a big one. And because it doesn't do IR, it doesn't do the proximity stuff either, whereas APDS 9999 does have both IR readings, so it can tell you just how much IR is in the environment, but also it can use that IR sensor as a distance sensor, and then it's set up for proximity so that you can like get a trigger whenever it changes. Basically, it can be like sort of passively detect that something moved into the range. Was using a TCS 34725, and the OPT has been better thermal shift characteristics. I gotcha. Yeah, so that part I don't know much about either at all, as far as like how it behaves under different temperature environments. I don't know at all on that front. Okay, so I want to make sure like that red is reading red and green is reading green and blue is reading blue. Ideally we would check IR as well, but I don't have an IR LED hooked up, so we're not gonna be able to do that one as easily. And I think that it could, I think given the NeoPixels and the sensor, it should be able to kind of like run through a series of checks to like make sure that it's kind of working, basically. We are going to ask our friendly robot Claude friend to help us with that, and I'm gonna actually CD into the Circuit Python driver now because we don't really need the rest of the context. Okay. Because we don't even really need NeoPixel basic test, honestly. Delete that. So I'm going to tell it to look at simple test and kind of see the way that it is using the NeoPixel and the sensor. I'm going to tell it that the sensor is pointed at the NeoPixels, and then I'm going to ask it to run through and verify that the color sensing and the light sensing and the configuration options related to those things are all working as expected. It should be able to do. We'll put this maybe back to light for now. Okay, so PDS 49s NeoPixel test.py that verifies the, well, please write, I'm gonna say please write an example script. I'm not gonna call it a test there because what I don't want is like a PyTest, right? I'm not trying to get a PyTest thing. I'm trying to get a thing that runs on CircuitPython that is gonna like set the NeoPixels to red and then read the color sensor and make sure that it was red. Go through a bunch of other colors and do the same. Write an example script that verifies that the color and light sensing capabilities of the Adafruit APDS 9999 iDriver color and light capabilities are working as expected. What is up, Paul Cutler? Nice to see you, my friend. So verifies that those are working as expected. Have it cycle through multiple colors and light levels and ensure that readings from the sensor match expected values. What is up, Yano? Nice to see you as well, my friend. Yeah, that's maybe enough of instructions. We'll see. I did forget to tell it about the NeoPixel. Hopefully it will find it. Probably will find it. But it would have been easier on it if I had just pointed it to the file, I'm sure. The simple test file. Yeah, it looks like it's on the right track with its plan. Bringing along. I'm trying out Sonnet 4.6 instead of Opus. I know Opus is kind of higher tier, essentially. But I'm, like, trying to understand the differences. Okay, it's trying to run the code. Well, there's probably my fault because it has a... Actually kind of curious at what all it... But it's trying to run the code here. Most likely, it's probably trying to run the code... Well, it's trying to hook up to the serial port to see the output of the running code. The reason why it's probably trying to do that is... the way this is loaded up, I have a skill loaded into context for it that's like run CircuitPython code skill and connect to serial and get the output back. Um, but the thing is, the device we're using, this fruit jam, which is underneath this thing shielding my eyes from blindness right here, is not plugged into the thing that this agent is running into. I do have it plugged into there sometimes, and it can like run code from there on a CircuitPython and read the results back, which is super helpful. And in this case, it looks like it would have done that for us. It would have actually tested the code and then verified that it worked. But it's not actually plugged into there, so. It does look like it's basically 150 milliseconds. I don't know. Is that fast enough? So I think default was 100 milliseconds in the resolution. $100. Okay, so default of resolution is 2. I don't know if it will have. See if it did the resolution stuff or not. Average readings. Takes multiple readings. NeoPixel. It did do only one NeoPixel, and it basically did it correctly. I'm gonna change it to 5 though, because I do have there's 5 on the fruit jam. It is setting the brightness to 0.3. I don't know if it's gonna. It's not saturated, but still well above the floor. Doesn't look like it's gonna change that. Probably it's set to 9x gain. So give it some sleep, settle time, average the readings, make sure that red dominates, green, blue. These are all formulaic. Set the neopixels and then calculate to make sure that whatever color is supposed to is most dominant, has the highest reading by a certain threshold compared to the other readings. Check the lux as well, calculating that from green. Dark, so it will make sure that it reads correctly when they turn off. Main status sanity check. Probably should be done before the others, but okay. So it's not, it is testing all the color. Well, it's testing, the 3 sort of primary colors, but it's not doing any of the in-betweens. It's also not doing any other like resolutions or gains. Which is fine, but I just see if that was the case or not. So we will take this. I will this one, and this will now be APDS 9999 simple test. NeoPixel test will go here. I'll probably use different names since the simple test currently has NeoPixels as well. Or maybe I'll take the NeoPixels out of the simple test. Yeah, probably the simple test shouldn't do NeoPixels. It should just rely on you to shine a light from something else on it. We should be able to see the colors as it works here. So it's doing red, testing green, testing blue, white, turning off. I'll test pass. Nice. And we could verify kind of that it is actually working because we could do something. So like for blue right here. Oh, actually it's only setting 1 pixel. Let's change that. Right, we don't, let's see. We have to do more than this. These have So what we're going to do, though, is we're going to verify, we're going to kind of sanity check that the color testing is working by cheating one of the colors to do a different color and make sure that the test fails. So like for the blue one, if we change that to actually set the lights to red instead, then the test should fail. One or more tests failed. Oh. So blue failed. Yeah. The red ended up dominating because it is actually at 55,000 and blue is only at 1,000. Green is probably artificially inflated because there's also a green LED, right? The power LED, just trapped under there as well, putting in some green light. Okay. Okay, good. So we know the test would fail if the thing was not working, and we are seeing that the test is passing when it is not intentionally to fail. Okay. The next thing that I would like it to try, I'm actually going to copy this back. The next thing I would like it to try to do is test the interrupt. So we have a light threshold interrupt, a light threshold, so light threshold high and low. I wonder if it will go so far as to like set a color of light and check a reading and then set the threshold based on the reading and then sweep through the range. But in any case, I want to have it try to check that the interrupt is working as expected, but I have the interrupt pin wired up with one of these little grabby thingies. I don't know the name of this kind of probe thing, but it can kind of like squeeze out and it's got a little grabby thing on it. But I don't know if this is actually going to work. And I don't have the other end plugged into anything. So we need to... I presume that interrupt pin would get pulled... Oh, hey, light sensor interrupt. When it goes above the upper limit or below the lower, I should call them thresholds, not limits, because that's what it says. For a specified number of readings. Does it set the pin high or low? That's really what I'm trying to see. Doesn't say. Earliest programmable interrupt. Programmable interrupt. Dedicated interrupt pin. Open drain. All right, well, what we can do is use digital I/O to, well, we need to hook it up to a pin, and then once we hook it up to a pin, we can use digital I/O to read the pin. We can see if it's high or low by just default when nothing's happening, and then we should be the opposite when it triggers if everything actually works. What I need is the Fruit Jam pinout because I do not know the pinout of this chunk here where all of the I/O pins are. All right, so this is rotated like up this way, right? It goes horizontal here. This side is over here. I just need a digital pin. Not super duper important. Which one? Bunch of this row is labeled. So the top row is labeled, the bottom row is not. So I could actually just use like D6, 7, 8, 9, or 10 pretty easily, and it is labeled there. So let me plug that in. It's probably going to be not super easy for y'all to see because my hands are going to be in the way, but... And then we do have to deal with the fact that we're flipped around. I'm going to put this light, which is probably going to overwhelm the camera. Sorry about that. I believe I have that plugged into D8. So we should be able to use, like I said, digital I/O. Check pin D8, and then hopefully... Oh, but we have to set the pull. All right, well, we'll see what we can do. Interrupt input D8. So I guess we'll pull it. They're like interrupt pull. Okay. Well, my gut instinct is that we would pull it low and then it would put itself high when it triggers. Like a good baseline guess. So the interrupt pin. In fact, I'm just going to insert another little loop in here. Print. Okay, so the value is always high. Even though I set it to pull down, actually. Interesting. Okay. So what I wanted to do is... interrupt test. We need a debouncer. Debouncer? No, to clear the interrupt pin. Do any of the Arduino examples use the interrupt pin? Does it have the? It has the interrupt threshold interrupt. Okay. This does get pulled up. patch to interrupt, so it seems like Arduino has some fancy patch to interrupt thing. I don't know where that's from. Is that from here? Nothing. Okay. You could tell it to read this, actually. You have... So you can have the threshold for both active, and then you can find out which one got triggered with the main status. Okay, fair enough. That's pretty cool. Okay. So yeah, let's have it try to make a threshold interrupt test that's similar to that, but using... Python. I'm actually just going to delete all of the NeoPixel example stuff instead of starting from it. But what we will do is we will give it the... Actually, we saw it was a... 1 second. So we should be waiting for that to go low when it triggers. Put this... to interrupt in... Okay. And I am going to start a new context, because I suspect if we continue this, it's gonna keep sending the whole session back every time. I don't think we need. Can you please work on EDS 999? On the circuit Python interrupt example, APDS 9999 interrupt test.py examples inside there, because we're in the root of this right here is where the where it's at, so like it will start looking there, the bot's running. So examples, this is where that's at. Screen here, you can reference, actually let's just say reference examples threshold interrupt.ino interrupt.ino for an Arduino example. For the functionality in it. Circuit Python. And it should read the digital I/O stuff that's there already as well, so it should hopefully know how to do the pin input based on that. What is writing? I have a complete picture. Sure if it read the full driver as well. It might have read the full Arduino driver. It would have had to go up to do that, but okay. Yeah, definitely read what was there because it found that this was D8, and that's the only place where it would have found that. But is doing the whole like let me run this code for you thing again. Oh. Yeah, I should turn off that skill probably when I don't have it plugged in. I wonder if I could make it smart enough to know it's like not plugged in and know that it can't work when it's not plugged in. That'd be interesting. Okay, interrupt test. Deconversions. We have all the enabled changes. So these are all properties, right? CircuitPython land, we use properties instead of getters and setters. Device isn't, yep. Yeah. Should take the, should disable the skill for now. But yeah, or I should plug it into there, I guess, but. So it is trying to do proximity. As well. I kind of want to adjust the lights for now, but that'll be fine. I can, I'll have to something for proximity. RGB. We'll come up with a better name probably. Make sure it did do the pin, D8, pull up. And it just take all the same values from the other one, which I don't know if those are going to be good for what I've set up here or not, but. Actually, so one thing is it's not using the NeoPixel. I would like it to use the NeoPixel to test. The light interrupt instead of instead of just telling us to turn a light on. But we can test it this way first. R2C peripheral inputs. Oh. Board. Change that. Okay. So proximity interrupt is happening a lot, but that's because I think like right now it's face down, basically just pointing at this thing, right? Up here, it is still just triggering. Oh, zeros? So one thing that's interesting is that the value of the proximity goes up the closer the thing is to it. The closer it goes up a little bit. If I go further back, it gets lower. So that's not just like a distance reading. Actually just gonna turn off the proximity one for now. Proximity interrupt threshold enabled. I don't just want to set it, or I don't just want to comment it. Really, I guess what I want to do is set it to false. Okay. And now it is still getting proximity interrupts, actually. Turn the proximity sensor. It always trips. Anyway. Maybe the status like always shows triggered if you have it disabled. Okay. So the next thing we're seeing is that the light interrupt is happening pretty regularly, and it is printing the green. Came from RGBIR 94 right now, and that green is actually just coming from its own power LED over there, I think. The threshold for that is what? For that is less than 1,000, greater than 50,000. Well, so the thing is, it's not going to be, yeah. Why don't we say less than 50? Why don't we say less than 50? Okay, and then it's still printing here even when it doesn't trigger, so I don't really want that. I kind of want it to just print when it triggers. I mean, this is good for troubleshooting, but now it should just be waiting. And if I shine a light on it, it's going to blow out the camera, probably, sorry. Can start getting the interrupt there. If I take it back away, it stops. Cool. We could probably, since the threshold is so low, we could probably also trigger it like this by giving it its own green light back. Look like it. To turn this back on to see where we're ending up there. Oh, right. Because that's below. Yeah. So we're not below 50 anymore. Now we're, in fact, quite a ways above. We're 6 times 50. We're in the 300s. Okay. All right. This one, it does mimic the Arduino one, which is what I asked it to do. So it did what I asked, but I would actually like one of these that's kind of reimagined to be more like this functionality test one, where it's going to also use the NeoPixel and then run its own, like, set the threshold to this and then change the NeoPixel to be above or below or in the threshold range, and then verify that the interrupts are working as expected. So it should go from below the minimum, make sure that it's triggering, kind of ramp itself up until it gets to the minimum, make sure it stops triggering, ramp all the way up through the main range, and then exceed the maximum and go and make sure that it's triggering once again. And I think it could do that whole kind of sweep all by itself with a NeoPixel in one code file, which would be nice because it would give us more assurance that all of the thresholds are working correctly. Right now, we kind of only really tested the lower threshold, essentially. But yeah. But we are more or less at time, so that is basically going to do it for the day. I will be back on Tuesday for the new stream at the new time. Tuesday mornings, it is 11 a.m. Eastern Time. 11 a.m. Eastern Time, 8 a.m. Pacific Time, and it is also 10 a.m. Central U.S. Time. Those are all U.S. time zones. Daylight Savings Time is this week in the U.S., so if you do not have Daylight Savings Time wherever you're at, or if it doesn't work the same way as it does the U.S., and you want to tune into the streams, then double check, because I will be changing times this weekend, so next week's streams will be adjusted according to the new daylight savings time in the US, as confusing as it all is. So Tuesday I'll be back. I do normally stream on Saturday mornings at 10 a.m. Central Time as well, but I will not be tomorrow, so no stream for me tomorrow. That one's over on my own channel, not the Adafruit channel, but like I said, no stream tomorrow. I will be back Tuesday on the Adafruit channel. We are workshopping different names, so the Tuesday show might not end up staying Deep Dive. We might come up with a different name for that, but for now, I am just calling it Deep Dive with Tim, and that is on Tuesday. I'll be back for that. As far as I know, I think Scott's planning to be back next week for Deep Dive here in the Friday slot, so unless anything changes, or unless I just don't actually know, which is possible too, I believe he's planning to be back next week on Friday at this time, which is 5 p.m. Eastern, 2 p.m. Pacific, 4 p.m. Central. So thank you to everyone for watching. I hope you all have a wonderful rest of your Friday. Have a good weekend and all of that stuff. I will see you back here on the Adafruit channel Tuesday for my stream in the morning. Thanks for watching. So long. Farewell. See you later.